Hello everyone. Today we're going to make a video on why AI is different. Why the AI investment opportunity is so significant. This is going to get a little bit of sciencey with today's video, but the scientific information that I'm going to be presenting is designed to give you the bigger picture to help you see the forest rather than focusing on the individual trees, so to speak, within the investment opportunity and help give you some context as to why AI is such a significant investment opportunity. All right, so first of all, we need to have some sort of framework for understanding how AI works. And the best way that I can explain how AI works is to first of all show the relationship between all the stuff, all the ideas that humans deal with, and how AI is able to process these ideas. So if you start at the I'm going to draw a diagram that shows at the very center, we have the world of investing, okay, and business, okay, operate. You can actually put economics into this little circle here. Wrapping around that is the world of technology, okay? So the idea behind this diagram is that everything that operates and works within the world of investing in business and economics must exist within a framework that is technologically possible. Okay? So everything that is technologically possible is able to be exploited commercially within this little circle here. So there's probably still things that are technologically possible, even in the year 2025. There are things that are technologically possible that aren't currently being commercialized in terms of business opportunities. Okay? Wrapping around the technology envelope is the world of physics, okay? The science of energy, matter, the universe itself, the rules of how our universe works, okay? And you can break that down into categories like classical mechanics, quantum mechanics, relativity, stuff like that. Wrapping around the world of physics is the world of math, okay? So, the idea behind this is that there's no technology that exists that goes beyond or outside the laws of physics. In other words, all the laws of everything that's technologically possible operates within the envelope of what's physically possible, etc. Everything within the the investing and business opportunity stuff all has to obey the laws of physics also, or else it's just not a commercially viable enterprise. Um, and likewise, nothing within the laws of physics can be possible that doesn't obey the rules of mathematics. Wrapping around the world of mathematics, what a lot of people are not aware of is a field called meta-mathematics. Mathematics. All right. There's meta-mathematics. Okay. And meta-mathematics has to do with what can be described as formal systems. And formal systems go outside the world of math and just deal with things like symbols and rules of association for these symbols. And so since most people are not familiar with the domain or the subject of meta-mathematics, I'm going to give you a very quick example by creating a formal system, a very simple formal system. In this formal system, we have statements. Here's a statement: triangle plus triangle uh, is equal to square. Okay. Clearly, I'm borrowing symbols from mathematics in this formal system. I'm going to abstract this statement and just create something that's a little bit simpler and say, okay, if we have a string of triangle, triangle, that must be followed with square, okay? If we have triangle, uh, square, and then upside down triangle, okay? We also have a statement of square, tr right side up triangle, and right side up triangle. And if we create enough of these series of statements together, we will eventually figure out that there are rules of association between the triangles and the squares. First of all, one rule is that they seem to come in groups of three symbols as a statement. Um, this could be interpreted as like if you add a triangle plus a triangle, that's equal to a square. If you have a square and subtract a triangle, you get a triangle, etc. So that's kind of the idea behind a formal system. It's a more abstracted version of mathematics. All right. So why is this important to know when thinking about AI and understanding how AI works? Well, contrary to what is stated, the language that they use in computer science of AI as being large language models, that's actually not very accurate description of what people call a large language model. Is not really a language model at all, because language would imply like English or Spanish or Chinese or some sort of, or maybe even computer language. But what they really are, these large language models are actually uh, formal system processors. Okay, they are um, they are entities that can absorb the symbols and the rules of association for uh, any domain of symbols. So, for example, uh, if we have a picture of a cat, okay, a cat has a certain kind of there's rules about what a cat looks like. Okay, it probably has some like whiskers, it has fur, it has a certain general shape, and all cats have certain common shapes to them. Okay, and there's four legs, and the legs are attached to a body, and those are some of the rules about how a cat is put together, and that's very different than a centipede. It's very different than a tree. There are rules about how trees appear. They have a trunk, there's branches, there's, either leaves or needles or something like that. Those are the rules of association for the different shaped objects that are on trees. And AI is able to absorb any and all formal systems, anything within math, which is a formal system. Physics has symbols and rules of association. They're called equations. Technology, the technological devices have these symbols and rules of association. They all are examples, can be boiled down into formal systems, and AI is able to absorb, process, and then generate new information and new knowledge based on these formal systems. So let's take a real quick look at what's different between AI systems, how they work, and the old model of computing. The old model of computing is based off of the central processing unit. Okay, so think of a chip, a basic kind of like Intel type of chip that's found in a PC. It processes one chunk of data at a time. Okay, so a CPU, chunk, 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 processing one chunk of data at a time. Used to be 8 bits would be a byte of data at a time, and then there were 16, and then 32, and then 64, and then 128. This allowed CPUs to process more data per second in terms of like megahertz, gigahertz. Um, the problem is that the scaling laws that are known as Moore's law for CPUs, it had been well known decades ago that there were upper limits in the laws of physics that would prevent these CPUs from processing more data. And that was several decades ago when the people from NVIDIA got together and decided that they were going to create a new paradigm for chip architecture called the GPU. Okay. You may have heard of GPUs before. Similar in design to a CPU. And by the way, the reason that these things are called GPUs is because at first they were just used for graphics processing. All right, things like computer games and stuff like that. And they would pair a GPU graphics accelerator to a CPU in a gaming system, and it would help generate the imagery that makes gaming an immersive experience with lots of video content. So graphics processing unit was the original name for it, but they're not. We when it comes to AI, we're not just dealing with graphics anymore. All right. Anyways, these GPUs have basically like multi-core processing is what's going on. And from a physics standpoint, you can consider this to be the fact that instead of processing just one chunk of data at a time, chunk, they're able to process massively parallel processing operations all at once so that you can process much more data per second with a GPU than you can with a CPU. All right. So what's going on at the very basic level of the computer science for AI? We are mimicking the human brain. Okay. In terms of AI, we are talking about different layers of nodes. Okay. We have what's called an input layer, and let's say we've got an input layer with 3 nodes here. We have something called the hidden layer inside of a large language model. All right. And then we have, computer science is all about inputs and outputs. Then we have an output layer. And let's put, say, in our model of how these things work, we're going to have 3 and 3. So what happens with these large language models is that there's something involved called training that establishes the weights or the strengths of these connections between the input layer and the hidden layer, okay, for different ideas, different concepts. And for example, let's go back to the example of a cat versus a tree. The weights between the nodes in this hidden layer for example, anything that looks like a cat is going to have a certain pattern to it that will generate an output that is going to be different than, for example, the word or the concept for a tree. Okay, the tree may have different weights, okay, different weights between these hidden layer nodes and a cat. And that's why the output, when these different ideas are put in to AI, is we get these different kinds of outputs and recognition. And basically what we're doing with these nodes and the connections between the nodes is we're mimicking how the human brain operates with neurons, okay? Neurons and the cells inside the brain have these dendrite types of connections, and different ideas light up and connect different patterns of nodes between the neurons inside the human brain. And the structure, there's an isomorphic or a similar structure between the hidden layers in AI systems and the nodes and connections inside the human brain. So we're able to mimic human thought and human processing with AI, these large language models. All right. So why is this significant? Well, here's where we get to some applications that start to get us close to the world of investing in business. AI is a universal function approximator, and humans have never had this before. This is something that is completely new to humanity, the ability to approximate the functional relationship within any formal system. So what am I talking about? I'm going to abstract this and say, here's our AI, and we have inputs, and we have outputs. And as you probably know, we can input text into things like ChatGPT, for example, and we can output text. So it could be a paper, and it could write a summary of a paper for us based on the prompt input. And it could be, we could ask it to write us a paper, and it could generate a paper, which would be in the form of text. In addition to text, of course, video can be an input into AI, and we can generate video out. Or we can put text in and generate video as an output. We can ask things like Sora to like, hey, can you make a video of a cat walking across the street for me with a monkey on its back? And boom, it generates a little video clip of what we asked to do. Text, video, voice, or sound, we can call that, can be an input. Sound can be an output, or voice. ChatGPT, by the way, is really holding back on releasing their versions of their ChatGPT models that generate voice, because it could be used to mimic your voice. And once the AI, if people get a hold of an AI that is able to mimic your human voice, it'd be really easy to fake things like fake phone calls, and scam artists could use it. So that's kind of something that a lot of these AI models are trying to hold back on releasing, because it's actually too powerful. Uh, Image, of course, can go in, and an image can go out. Okay, you can give it an image and ask it to edit it. And you can have sensor type inputs that can go into it, and then you can have actuators go out. Okay, so any type of transducer type of input can go that, or you can have sensor information go in and video go out, or video go in and actuation going out. So let's talk about one application of this. Tesla full self-driving. Cameras, 8 cameras in the car. The AI is absorbing video of all the best drivers that drive Teslas, constantly goes into the AI. What are they generating as the output? Once the AI has processed how the symbols, which would be the street signs, are symbols, the rules of association for how cars and people interact with each other, all the driving laws get absorbed and embedded within that neural network into those nodes in the AI. And the actuators are things that control the steering, the accelerator, the brake pedal, turn signals, brake lights. These are actuators. These are things that are actuated by all that video input that's been fed into it, into the AI. All right. So we have universal function approximator. Humans have never had this before, okay? Computer science used to be based on retrieval-based systems. Yeah, we had lots of servers, lots of data stored on servers. People had to hunt around in order to find information using tools like Google. All right, now we can have basically pretty much all of human knowledge embedded within the AI, and we can dynamically generate things. We can generate content. Um, this is opening up the really interesting investment space. All right, so to understand how big this is, we need to think about something called the capitalization of human labor and how that has created business opportunity. So we're going to connect these ideas to how investments have turned out. So let's look at a very simple example of the capitalization of human labor. Okay. As you probably know, labor is one of the most costly aspects of running any business. In a school, it could be 80, 90% of the cost of operating. In a corporation, it could be 60, 70% of the cost of the operation, et cetera, is just the people. All right. Capitalization of labor. Cloth diapers versus disposable. All right, kind of a silly example, but it illustrates the idea pretty well. Humans had to spend a lot of labor with babies, all right, cleaning those diapers. When I was a kid, we were just beginning to get these things called disposable diapers for the first time. This was a new technology. All right, lots of labor with cloth diapers. Once we had disposable diapers, then all the time that people used to spend cleaning, washing, drying cloth diapers, almost all of that is gone now. I'm sure some people still using cloth diapers, but almost everybody uses disposable now. That conversion of the human labor of dealing with cloth diapers has created 70 billion in market capitalization for companies such as Procter and Gamble and Kimberly-Clark. Okay, they own most of the market. So this human activity has resulted in $70 billion of the stock price of these companies. Let's look at another example. Um, Farm equipment. 1850s, we had 55% of people in the United States worked on 1850s worked on farms as farm labor. By 1925, that percentage went all the way down to 25%. And in the year 2025, only 1% of Americans provide farm labor on farms. How? Mechanization of labor in farms, right? We are talking about steam engines at first, then we have internal combustion engine type tractors, combines, things that shuck corn automatically, harvesters, and this thing about moving along from human-based labor for agriculture to mechanization and automation has driven companies like John Deere and Case New Holland to have about 75 billion And this is the lower end of the range. We're actually talking about maybe 160 billion on the high end, depending on how you categorize it. The market capitalization of John Deere and New Holland, it has been derived from the capitalization of the human labor for farm equipment. You can go all the way down the list and say things like fast food restaurants, McDonald's, capitalizing the human labor of making meals, assembly line processes for that. There's boom, 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 boom. Okay, all these little segments. Coca-Cola. Okay, people used to make teas them from scratch. They used to make, homemade lemonade from scratch, and people still do that. But for the most part, what people do nowadays when they want that type of sweet beverage is they just grab a bottle of a soda or bottled water or something like that, flavored drink. And that has created this gigantic company as the conversion of that type of human labor. So, why is this a big deal? This is a big deal because each of these businesses that I just talked about has only been able to convert a very, very small segment of human labor into capital. Yet, those very small niches or segments of human capital have been converted into massive stock price appreciations for these companies from startup until today. And what AI is able to do is, because it's a generalized universal function approximator that mimics the human brain, is we have the potential in front of us as an investor to grab a hold of the future capitalization of almost all the remaining human labor. And in 2025, there's about 40 to 60 trillion with a T, okay, of human labor that is done around the world. And AI is slowly chipping away and absorbing that human labor. All right. Um, some of the things that humans used to do that AI is already swallowed up or in the process of swallowing up. There's a company called Chegg that gives like students homework help. Okay, boom, that company has almost been decimated, destroyed, because they're humans that would be tutoring and helping students is being replaced with Chat GPT. Legal research, okay, paralegal type of work, that is disappearing for the most part because AI is able to automate almost all of that basic level type of legal research. Entry level programmers, okay? Programming for the most part can be automated and done by AI very, very well because it fits in very easily as a formal system, these programming languages. And so we're actually starting to get unemployment for college computer science graduates at levels that we have never seen before. I mean, it used to be a guarantee that if you had an engineering degree or computer science degree, you had a job coming right out of college. In the year 2025, that's actually not the case, and that's it's you know it's scary. I'm sure it's scary for them. Every time we have a new technology, a technological transformation, there will be winners and there will be losers. Okay. Uh, by the year 2030, by the year 2030, AI is going to, I believe, absorb about 5% of all human labor. Okay. And so 5% of the 40 to 60 million dollars in human labor. We are talking about jobs that are going to be, in a sense, taken over by AI. Uber drivers, okay, with full self-driving type of technologies proliferating across the United States. Call centers, if people that work at call centers and handle customer questions and stuff like that, AI will be handling almost all of that work. Order takers at fast food restaurants, okay, is going to be substituted with AI agents with companies like SoundHound. Package sorting in like warehouses, fulfillment centers, pick and place warehouse type work, all right, for orders. Legacy media is going to be is being disrupted, okay? People are We're going to have a democratization of entertainment where individual people will be able to generate their own like little videos and their own little movies, and it's going to begin to chip away at the people oriented old school model of creating that type of entertainment content. Companies that are winning right now: Nvidia, OpenAI, Palantir, SoundHound AI, Tesla, and companies that provide the electrical energy that's needed to power these gigantic AI data centers are also a constraint point in the rollout of this transformation of a society and the conversion of human labor into capital. By 2040, I believe about 50% of human labor is going to be swallowed up by AI. Things that people used to do is going to be done by AI. Most accountants, most tax preparation, janitorial type service will have automated robots that will be cleaning commercial buildings, laundries, almost all fast food workers. Most Hollywood film and TV production is going to be automated. Ad agencies are Meta is doing a great job in creating AI-based ad agencies that are, in a sense, built right into the company. Truck drivers, warehouses and factories eventually are going to go dark. What does that mean? You're not going to have a human inside the factory. You can be dark. The robots will be able to automate it, be able to see in the dark, automatically go through their processes. So we'll be able to just turn off the lights and let the AI and the robots take care of everything. I can't predict what's going to happen in terms of who the winners are going to be out all the way out to 2040. But a good starting point would be the companies that are pushing the forefront in AI right now. And so the opportunity from as an investor standpoint is going to be enormous. Okay. And all I can say is it's a good idea to keep this framework of the bigger picture of what's happening in society in mind when making those portfolio allocation decisions. All right. Because the companies that are going to win in a really, really big way. And you can redirect some of those future profit flows into your own bank account if you keep these things in mind. All right. So I know this has been a long one. This has been different. All right. Lots of sciencey type of information. I appreciate you taking the time to watch this video. If you like this, think about clicking the like button on this video and maybe even sharing it with someone if you think that it would be of interest. And I'm Jeff Whitaker. This has been Top of Funnel. Thanks for watching.